Hi Gr10s, this is JP. This video will help you in part A, sketching functions. Let's start by looking at what is a function. A function takes an input and transfers it to the output, right? So a function does something to an input, all the x values, right? So input goes into the function, it works on it, right? And then it kicks out an output. Input are all the x values and output all the y values. Let's look at an example of a function. So y is equal to 2x squared plus x. This consists of x variables and a y variable. X the input, y the output. So if I would have an input of, say for example, 1, where x is equal to 1, that would mean that I let x is equal to 1 go into my function, right? My function is y is equal to 2x squared plus x, and I'm going to get an output when 1 goes into the function. What does that mean? That would mean that you would substitute 1 into all the x values. So 2x squared plus x, right? And you're going to substitute 1 into all those x's. What's going to happen if you substitute 1 into all the x's? You're going to get 2 times by 1 squared is 2, plus by 1, so that is equal to 3. So when the input is equal to 1, what's the output? The output is equal to 3. For a different input, say for example, x is equal to minus 2, what's going to happen then? So what we're going to substitute, put minus 2 into this function, and then we need to look at what is the output going to be. In other words, we're going to substitute minus 2 into all the x's. So I would encourage you to put brackets where all those variables are that you're going to substitute it. So it's 2 times by minus 2 squared plus by minus 2. So that means it is minus 2 times minus 2, eh? So which is 4 minus 2, which is equal to 8 minus 2, which is 6. That means when you feed minus 2 into the function, you're going to get an output of 6. So what does the input and the output mean? So when x is equal to 1, y is equal to 3. When x is equal to minus 2, y is equal to 6. That simply means those are coordinates. Remember, coordinates consist of an x coordinate and the y coordinate. So when x is equal to 1, y is equal to 3. When x is equal to minus 2, y is equal to 6. Y is equal to 2x squared plus by x. A different way of writing that, just a different notation, is to say f of x is equal to 2x squared plus by x. Fear not, this is not too bad. F of x is the same as y. This means the function of x with respect to x. Okay? So in other words, if I have an input of 1, okay, so then what I'll do is I will say, well, this is where x is equal to 1. You follow? X is equal to 1. That would mean I'm substituting 1 into all my x's. And what is that equal to? What happens if I substitute 1 into all my x's? You're going to get an input, f of 1 is equal to 3. Alright? So x is equal to 1. This is f of 1, which is equal to 3. The same if I substitute minus 2 into all my x's. That another way of writing that would be to say f of minus 2. Don't freak out about this. F of x is the same as y, right? So if I substitute, if my input is minus 2, x is minus 2, right? So you substitute minus 2 into all the x's, okay? And what is f of minus 2 equal to? That is equal to 6. That means x is equal to minus 2, and that would mean f of minus 2 is equal to 6. What we're then going to do is plot all those coordinates, right? And then draw curves. Okay, so what I want you to do is to locate part A of that Google Doc, and we're going to sketch 3 functions, right? We're going to sketch y is equal to x squared, y is equal to 8 over x, and we're going to substitute, to sketch y is equal to 2 to the power of x. So those are on pages 2, 3, and 4. So let's look at the first question there, where I ask you to sketch y is equal to x squared. So the function here is y is equal to x squared, and then we've got certain inputs, right? -3, -2, -1, 0, 1, 2, and 3. Okay, why did we choose those specific inputs? Because on the Cartesian plane, those are just on the left-hand side, on the y-axis, and then just on the right-hand side, right? So it's always safe to include negative and positive x values very close to the y-axis. Okay, so -3, -2, -1, 0, 1, 2, 3, those are inputs. So y is equal to x squared is exactly the same as saying f of x is equal to x squared, right? So y is f of x. You might be thinking, but why would you make it more complicated? Why would you now give it another name? All right, why would we do that? Good question. So if we look at the first input there, -3, okay, so it will help us to say that when x is -3, right? This just means when x is -3. When x is -3. So what you're going to do is you're going to substitute -3 into all the x's. So that would mean it's x squared, right? So you're going to square -3. -3 times by -3 is going to give you 9. So when x is -3, y is equal to 9. When x is -2, right, you substitute -2 into the x. -2 squared, what is -2 times -2? That is equal to 4. So when the input is -2, the output is 4. When the input is -1, what is -1 times -1? That is going to equal to +1. When the input is 0, what happens if the input is 0? 0 squared, 0 times 0 is equal to 0. When the input is 1, 1 squared, 1 times 1 is equal to 1. When the input is 2, 2 squared is equal to, 2 times 2 is 4. When the input is 3, 3 times by 3, 3 squared is equal to 9. And what we see here from the input and output, do you see there's symmetry that takes place? So it's 9, 4, 1, 0, and then it's again 1, 4, 9. So now what we're going to do is we're going to sketch this. But remember what I said earlier on? The input and the output produces coordinates. So in other words, what we've got is we've got a couple of coordinates here. So we've got the coordinate of, remember, coordinate consists of an x value and a y value, right? So we've got a coordinate of -3, 9. We've got a coordinate of -2, 4. We've got a coordinate of -1, 1. We've got a coordinate of 0, 0. We've got a coordinate of 1, 1. We have a coordinate of 2, 4. And then lastly of 3, 9. Now what we're going to do is we're going to plot each of those coordinates. So we draw a Cartesian plane. So we just did the Cartesian plane with trigonometry. So what do we have here? We've got the positive, remember the horizontal line is the x-axis, the vertical is the y. We've got the positive x values, the positive y values, the negative x values, and the negative y values, right? And please remember to label your axes like x and y. Okay, let's plot all those points. The first one we're going to plot is the point -3, 9. So what we have is we've got x that is -3, right? So x is -3, and y that is equal to 9, all right? So there's the first point we're going to plot. The second point we're going to plot is the point -2 and 4, right? X is -2, y is 4. Then we've got -1 and 1, x is -1, y is 1. 0, 0 is the origin, right? That's where x is 0 and y is 0. Then we've got x, which is 1, y that is 1. We've got 2, and we've got 4, right? So 2, 4. And then we've got 3, and we've got 9. So please, you don't need to make these dotted lines. It's just for illustrative purposes. So what we've got is we've got that beautiful curve there, and then there's the other arm of the curve. All right, so those points it's not straight lines joining those points, right? Not everything is straight. So yeah, so that's the first curve you've got, and it's a beautiful one. It is f of x is equal to x squared. All right. Next, let's look at the hyperbola y is equal to 8 over x. So you'll notice that I've changed the input here a bit. In the parabola we started at -3, -2, -1. The input here is -4, -2, -1, 1, 2, 4. Remember, we can choose this input. Why do you think I chose -4, not to start at -4 and not -3? Well, look at my function. 8 doesn't so lack a divide by -3, right? But 8 divides by -4 quite nicely. You know, you get an integer answer. So you can determine the input, right, as it suits you. So that's quite cool. Okay, let's go for it. So we've got the function here, y is equal to 8 over x. So y is equal to 8 over x is, of course, the same as saying f of x is equal to 8 over x. That would mean that we're going to substitute those inputs in, -4, -2, -1, 0, 1, 2, and 4 into the x, and get the output, the y value. So let's go. The first one, if you substitute -4 into x, that would mean f of -4. That would mean it is 8 over -4. What is 8 divided by -4? That is going to equal to -2, right? So you're going to substitute -2 into the y value. Then if x is equal to -2, that you'll substitute -2 into the x value, so it's 8 divided by -2. And what is 8 divided by -2? That answer is -4. You substitute -4 into the y value. If x is equal to -1, you would substitute -1 into the x value, so then you're going to get -8. 8 divided by -1 is -8. So when x is -1, y is -8. Then what we've got is, if you've got substitute 0 into x, right? F of 0, 8 divided by 0. Ooh, no, we cannot divide by 0. Remember, there's one rule, one thing we can't do in maths. That is divide by 0. So what does that mean? That means it's undefined. Okay, so there's not an output for that. When x is equal to 0, that answer is undefined. When x is equal to 1, so that means f of 1, so 8 divided by 1 is equal to 8. So if x is 1, y is equal to 8. When x is equal to 2, 8 divided by 2 rather, is equal to 4, right? When x is equal to 2, y is equal to 4. When x is equal to 4, what's going to happen then? So it's f of 4, 8 divided by 4 is equal to 2. So when x is 4, y is going to equal to 2. Now we're going to sketch it. Again, we've got a couple of coordinates now. We've got when x is -4, y is -2. We've got when x is -2, y is -4. We've got when x is -1, y is -8. Then we've got 0 and undefined. That's not really helpful, but I'm going to show you now what that is. And then we've got 1 and 8. We've got 2 and 4. And then we've got 4 and 2. So let's start by plotting those points. So the first point here, -4 and -2. So it's -4, y is equal to -2. So there we go. And then we've got -2 and we've got -4. So -2, -4, somewhere there. Then we've got -1 and we've got -8. Okay. And in a similar sense, if x was equal to -8, y would have been equal to, what is 8 divided by -8? It would have been -1, right? So, okay, so there's those points on the negative for the negative points. So that is the point minus when x is -8. So we've got, we can substitute any points we want into it, right? Let's start with 1, 8. So we've got 1, x is 1, y is 8. Okay, then we've got when x is equal to 2, y is equal to 4, and then we've got when x is equal to 4, y is equal to 2, And then we can also determine what is going to happen when y is equal, x is equal to 8. If I substitute x in the 8 in the equation, 8 divided by 8 is equal to 1, right? So 8 and 1. And look what happens here. This is strange, right? I mean, you can't connect all of those points. But what happens here is you've got a part here, a curve here, right? Going through all those points. And then on the top as well, you've got a graph going through all those points, right? So what we've got is, this is the graph of y is equal to 8 over x, all right? It's an hyperbola, okay? So what we've got is, we've got this 0 undefined here. What does that mean? So what is 0 undefined? That means when x is 0, y is undefined. Where is x equal to 0? This is right there, right? X is equal to 0 is anywhere on this y-axis. So that means the y-axis, right, is an asymptote, okay? So let's write that down. So it's an asymptote. Look at the asymptote on that axis. And then we've got the x-axis is also an asymptote here. So simply, what is an asymptote? We're going to elaborate on that a bit later. That would mean that this curve here, right, would tend towards this x-axis here, right? But it will never touch that x-axis. It will mean that this curve will tend towards this y-axis, but it will never touch it, right? Because what will happen, you'll divide by 0. X is moving towards the y-axis, but it will never touch it. Can't touch it. And x will move towards the x-axis, can't touch it. We call that an asymptote. Next, we're going to look at question 3 there, the exponential function. So what we've got is, we've got y is equal to 2 to the power of x. That's exactly the same thing as saying f of x is equal to 2 to the power of x. Okay, so again, we're going to have inputs, a couple of inputs there, -2, -1, 0, 1, 2, 3, 4, and we're going to work out the output. So that would mean that when so f of x is equal to 2 to the power of x, right? So if the input is equal to -2, we're going to work out what the output is. So, and what is 2 to the power of -2? That means it is 1 over 2 to the 2. Remember negative exponents. Negative exponent, 1 over 2 to the 2. And what is 1 over 2 to the 2? That means it's a quarter. And what is a quarter? So that is equal to 0.25. So that means when x is equal to -2, the y value is a quarter, 0.25. When we've got x is equal to -1, so -1, 2 to the -1, what does that mean? It's 1 over 2 to the 1, and that means it is a half, and a half is 0.5. That means when x is -1, y is 0.5. Next up, we've got when x is equal to 0, so that means 2 to the 0. Remember, 2 to the power of 0 is equal to 1. So 0, x is equal to 1. Then we've got when x is equal to 1, that means it's 2 to the power of 1, which is equal to 2. So 2 to the power of 1 is equal to 2. 2 to the power of, if 2, when x is 2, that means 2 to the power of 2. 2 to the power of 2 is equal to 4. So when x is equal to 2, y is equal to 4. X is equal to 3, that means 2 to the power of 3. 2 times 2 times 2 is 8. So when x is equal to 3, y is going to equal to 8. And then we've got 4. When x is equal to 4, that means it's 2 to the power of 4, which is equal to 16. 2 times 2 times 2 times 2 is 16. So we've got a couple of coordinates here. We've got the coordinate -2 and 0.25. We've got the coordinate of -1, 0.5. We've got the coordinate of 0, 1, 1, 2, 2, 4, 3, 8, and then lastly we've got 4 and 16. So let's plot these points. So first up, we've got when x is -2, what happens at -2? It's a quarter. Where would you find a quarter? Well, that is where x is 0, that is where x is 1. A quarter is a quarter of the way. So there's a half, quarter of the way. So at -2, you estimate there at a quarter. At a -1, it's a half. So it's like there, halfway between 0 and 1. When x is 0, it's 1. When x is 1, it's equal to 2, right? X is equal to 1, y is equal to 2. When x is equal to 2, y is equal to 4, so 2, 4. When x is equal to 3, y is equal to 8. And then off the charts here, when x is equal to 4, y is equal to 16. All right. So what do we have if we draw a curve through all of those? So we've got something that looks like this, right? So, and then it just keeps on going. So that is the exponential function. So f of x, y is equal to 2 to the power of x. So with the pandemic, of course, the rate of transmission is certainly exponential. We're going to look at a couple of real life scenarios around that a bit later.